Most of our work in Calc 2 will be done using the chain rule written as I have it here. So let's review first how you stated the chain rule, most likely in Calculus 1. You said that if you had two functions f and g, and you wanted to differentiate with respect to x, the composition f of g of x, that was f prime at g of x, or of g of x, times g prime of x. And you called f the outside function and g the inside function. So now all we're saying here, and again this will be what I'm going to use in Calculus 2, stating it this way. It's exactly the same thing. We're just saying that if u is a function of x, then this f of g of x is f of u. And if we want to differentiate it with respect to x, we get f prime of u, or g of x, times the derivative of u with respect to x, which we'll write du dx. So listen to how you read that, and when you read in the book or in your homework, read it with the correct words. The derivative with respect to x of f of u is f prime of u times du dx. Now, using this notation, we're going to review taking some derivatives this way, and there's 9 derivatives that you should know by heart that require almost no time for you to recall. First, of course, the derivative of u to the n. Whoops, look at that. I made a mistake on the first slide. I hope you can all see what mistake I made here. Let me get white and correct it. Is equal to n times u to the n minus 1 du dx. Let me write that again. N u to the n minus 1 du dx. Okay, so let's use this and do some examples. Let's say you're given this problem here. The derivative with respect to x of the square root of 1 plus x to the 4th. So we see our function u here is 1 plus x to the 4th, and our outside function is the square root function. So the derivative of the square root function is 1/2 u to the minus 1/2. So we get 1/2 times 1 plus x to the 4th to the minus 1/2 nu to the n minus 1 times the derivative of 1 plus x to the 4th, which is 4x cubed. So that's your derivative. Now, of course, we could simplify this to, well, 2x cubed over the square root of 1 plus x to the 4th if you wanted. Let's do another example. Do it in a different color, red. Let's say we want to find the derivative with respect to x of 1 over 10 cubed x. So I'm thinking of this as 1 over u cubed, or u to the minus 3. Maybe we would want to actually write that down. The derivative with respect to x of tan x to the minus 3. So my u is tan x, and my outside function is u to the minus 3. So I suggest that as we go through this video that you put it on pause right now and see if you can take this derivative, and then start up again and see if you got the same thing I did. Well, I'm going to be using nu to the n minus 1 minus 3 times tan x to the minus 4 times the derivative of tan x is secant squared x. So this is our derivative. Again, if you want to get rid of negative exponents, which is kind of nice, we could write minus 3 secant squared x over tan to the fourth x. Would be if you want to simplify it. The next derivative that you should know quickly is that the derivative, well, you learned the derivative of e to the x is e to the x. Or, stating it where u might be a function of x, we say the derivative with respect to x of e to the u is e to the u times du dx. Note just for a second, if u happened to be just x and we're just differentiating e to the x, well, if u is x, du dx is simply 1. So we do get the derivative of e to the x is e to the x. This is just a more general way of stating the derivative, and it will do us a lot of good to know it this way in Calculus 2 when we're integrating. Okay, so let's take an example. How about the derivative with respect to x of e to the 1 over x? We see that we have e to the u, where u is 1 over x. So our derivative will be e to the u times the derivative of 1 over x, which is x to the minus 1, so it's minus x to the minus 2. Or, nicest way to write it would be minus e to the 1 over x squared, or you might write minus 1 over x squared times e to the 1 over x. Any way you want. Let's try another example. The derivative with respect to x of e to the 3 sine x. Now put it on pause and see if you get the correct answer. U is 3 sine x. So we're going to get e to the u, e to the 3 sine x, times the derivative of 3 sine x, which is 3 cosine x. So the simplest way to write this, or the more what you see in textbooks, would be 3 cosine x e to the 3 sine x. Another derivative you learned in Calculus 1 is that the derivative with respect to x of 1 over x, of natural log x, is 1 over x. Or, more generally stated, the derivative with respect to x of natural log u, where u is a function of x, is 1 over u du dx. So, an example would be the derivative with respect to x of the natural log of x squared plus 1. You know, the domain of the function is only the values of x that make the argument, that is what's inside the parentheses, the argument of the function has to be positive in the case of natural log, but here it always is. So the derivative will be, well, u is x squared plus 1, so it's going to be 1 over u times du dx, 2x over x squared plus 1. Another example, let's do the derivative with respect to x of the natural log of secant squared x. Now, this has function composition with 3 functions. It's the natural log of the secant of x squared. So we might even want to write it that way, and then you put it on pause and see if you can do it, just using the chain rule twice. This is the natural log of the secant of x squared. So we have a nesting of functions here. The outside function is the natural log. The next one in is the squaring function, and the inside function is secant x. So I hope you can get this one. I'll do it now. Oh, excuse me, I should have the derivative here. Let me put that back in. You want to be sure that you write so that when you read it over it makes sense. If I had left the derivative with respect to x out, as I did, then it looks like we took the derivative. But really, I was just rewriting the function. Alright, so let's see what we get. The outside function is natural log, so the derivative will be 1 over its argument. So it's going to be 1 over the secant of x squared. I'll write 1 over secant squared x times. Now I want to multiply that by the derivative of this function, which will be, well, it's secant x squared. So it's 2, whoops, I meant to get blue, no, yellow, sorry, which will be 2 secant x to the 1 times, and now the derivative of the inside function, the derivative of secant, is secant x tan x. So we have some canceling that will happen here in simplifying. Secant x times secant x is secant squared x. So both of these factors cancel with the secant squared, and our answer is simply simplified to 2 tangent x. Here's a derivative I'm sure you all remember. The derivative of sine x is cosine x. Or more generally stated again, if u is a function of x, the derivative with respect to x of sine u is cosine u du dx. So let's say that u is the square root of x. Let's calculate the derivative with respect to x of the sine of the square root of x. If you want to write this differently, use exponents for the square root. It's the sine of x to the 1/2. Maybe you can see the inside and the outside function better. So now to differentiate this, well, the derivative of sine u is this, x to the 1/2. So the derivative of sine u is cosine u, oh, excuse me, whoops. Let me cross that out because I'm not good at erasing yet, is equal to the cosine of u, which is the square root of x, times the derivative of square root of x, or x to the 1/2, 1/2 x to the minus 1/2, using the power rule. So we could simplify this and write it as, how about 1 over 2 times the square root of x times the cosine of the square root of x. Let's do another example. The derivative with respect to x of the sine of the natural log of 1 over x. Can you see here that we again have 3 functions nested? The inside function is 1 over x, the middle one is natural log of 1 over x, and then the outside function is sine. So I'm just going to take the derivative of sine is cosine, so I'll have cosine, same argument, natural log 1 over x. Now I'll multiply that by the derivative of natural log 1 over x, which is 1 over 1 over x, times the derivative of 1 over x, or x to the minus 1, is minus x to the minus 2, so I'll put minus 1 over x squared. Use the chain rule 2 times. First, we had the derivative of sine as cosine. Notice that the argument was the same. Then we multiplied by the derivative of the natural log of 1 over x, and we got 1 over 1 over x, and then multiplied by the derivative of 1 over x. So let's simplify this. Let's see. 1 over 1 over x, that's just x, and the x cancels with one of these. So this is minus 1 over x times the cosine of the log of 1 over x. That's our derivative. Here's another derivative I'm sure that you don't need to memorize. You've already got this. The derivative of cosine u is minus sine u times the derivative of u with respect to x. So let's do an example. Let's find the derivative with respect to x of the cosine of the square root of x cubed. Well, again, when you see radicals, since we're differentiating, it's better to see them as exponents. So I'm going to rewrite this as the derivative with respect to x of the cosine of x to the 3/2. And now I see it's using the chain rule once. The derivative of cosine is minus sine, so I get minus the sine of, same argument, x to the 3/2, times the derivative of x to the 3/2, which is 3/2 x to the 3/2 minus 2/2 is 1/2. So that's the derivative. And I mean, that's simplified enough, but you could write it this way if you want. We could write 3/2, I guess I'd put the minus in front, minus 3/2, the square root of x, times the sine, and if you wanted to put it back in radical form, you could, the square root of x cubed. The derivative of tangent is secant squared, so we'll do an example. Let's find the derivative with respect to x of tangent. I have to make up a u here. How about x over x plus 1? The tangent of x over x plus 1. Okay, well, this is tan u, so I'm going to have secant squared u x over x plus 1 times the derivative of that quotient. So I could use the quotient rule and write the derivative of the top is 1, I'll write it out for you, times the bottom, x plus 1, minus the derivative of the bottom is 1, times the top is x, all over the bottom squared, x plus 1, the quantity squared. So that's right there, I'm using the quotient rule. You certainly need to know the quotient rule and the product rule so that you can just use them naturally. Alright, so let's simplify. Secant squared x over x plus 1 times, and this is x minus x, so we just have 1 on the top, and that will be times 1 over x plus 1, the quantity squared. That's our derivative. The derivative of secant is secant tangent. So we'll do an example. How about the derivative with respect to x of the secant of 1 over x squared? Now you might want to be thinking of that as x to the minus 2 for the sake of taking the derivative using the power rule. But we'll just use the chain rule. The derivative of secant is secant tan. So that's going to be secant 1 over x squared tan 1 over x squared. U is 1 over x squared. And now we multiply that by the derivative of 1 over x squared, which is minus 2 x to the minus 3. So it will be minus 1 over x cubed. And that's our derivative. Just 2 more to go. The derivative of arctangent u is 1 over 1 plus u squared du dx. You learned that the derivative of arctan x is 1 over 1 plus x squared. So this is a real important derivative because the arctan function is so important, and you'll see why on the other review video that I'll make for you. Okay, so let's find, as an example, the derivative with respect to x of arctangent 1 over x cubed, let's say. Arctangent 1 over x cubed. Okay, so you're thinking of this as x to the minus 3 for the purpose of taking the derivative of u with respect to x. Okay, so the derivative of arctan is 1 over 1 plus u. Now, I would change this just to x to the minus 6, but you can just plug it in like that if you want. 1 over 1 plus u squared times du dx, which is minus 3x to the minus 4. So that's minus 3 over x to the 4th. And let's simplify this. We have 1 over 1 plus, inside here is x to the minus 3, so that's x to the minus 6, and we're multiplying by negative 3 over x to the 4th. So we could multiply that in if we want. I don't know, we could go a long ways in simplifying this. Maybe just write minus 3 over x to the 4th plus x to the minus 2. Actually, you could multiply. I guess since this is a review tape, let's simplify it really to be the nicest. I would multiply this by x squared over x squared. Just 1. I choose x squared so I'll get rid of all negative exponents. And so the answer in its most simplified form, I think I'll go over here, would be minus 3x squared over x to the 6th plus 1, x to the minus 2 times x to the 2. So that would be the most simplified way to write the derivative. The last derivative that you need to know by heart is the derivative of arc sine, which is the derivative of arc sine u is 1 over the square root of 1 minus u squared du dx. An example we could do is the derivative with respect to x of the arc sine of, well, let's just do square root of x. You're thinking of this now as x to the 1/2, so you use the power rule when finding du dx. Okay, so we have 1 over the square root of 1 minus, I'll just put it in like this for now. Really, if I was doing this, I'd square it and I'd say 1 minus x times du dx, 1/2 x to the minus 1/2. Well, let's simplify that. That's 1 over the square root of 1 minus x times 1 over 2 times the square root of x. You could put those two square roots together. The square root of a times the square root of b is the square root of ab. So we could write this as 1/2 times 1 over the square root of x minus x squared. And I guess that would be the most simplified way to write the derivative.